All right, you guys, this is attempt number 6 to try to get this video going. I am not frustrated with you, but wow, our computer programs are not working here. This is Algebra 2, Chapter 7, Section 1, our first attempt at online school here. And our goal right now, I'm going to do this in a couple sections rather than all at once. But our goal today is to understand operations on functions. And in all honesty, we're just going to try to do sum, difference, product, and quotient of functions. That's going to be our first attempt here. And it's going to feel like review because I think this is the third time it has shown up this year. Sum is addition, difference is subtraction, product is multiplication, quotient is division. That's what we're going for here first. So if you're looking at it, what this is saying is if you have an f function and you want to add a g function to it, well, that works evaluated at x. That works by taking f plus g. You can just do it in two separate things. So over here, the example they're giving is, all right, f is x plus 2. G is 3x. So f is x plus 2. G is 3x, and then the parentheses here hold no purpose. So they're going to take x plus 3x, that makes 4x, and then the 2 just tags along there. So they just took the f function plus the g function and put them together. Now the same is going to happen here with subtraction. So we've got f minus g of x, and it's just saying take the f function, subtract off your g function. And so if we come over here, this is what f is. F was x plus 2. G is the minus 3x, or it's actually just a 3x. The minus was the operator in between them. So x take away 3x is going to give us negative 2x, and then we have the plus 2 on the end. And that is everything there. Multiplication, same thing. If you have f times g of x, you'll have f of x times g of x. And you can just separate them and do each part on its own. So here is f of x, that's that portion. Here is g of x. And what it actually wants us to do is multiply the two of them. So the 3x is going to get multiplied by the x. That makes 3x squared. And the 3x will get multiplied by the 2, which makes 6x. And that is f times g of x. And then division, they want f divided by g. So here is f divided by g. And then if you can reduce, you always do reduce. And the only qualifier they're going to put in there is that the g function cannot equal 0. And that's because you can never have a denominator go to 0. If you have a 0 in your denominator, just like with undefined slope, it's going to be an error that you cannot work with there. So moving forward, here are our two functions. And what I would tell you to do on your paper, if you were here, is clearly state what your f function is. So in this case, the f function is 3x squared plus 7x. You want to write that down. That is what f is. It's kind of like the rule. And then g of x is 2x squared minus x minus 1. So those are your two functions no matter what. And we want to take f and we want to add g to it. So f is 3x squared plus 7x. And then g, which we have to add to it, is going to be 2x squared minus x minus 1. Now, in this case, my parentheses serve no purpose at all. And actually, my error, I should have written this as f plus g evaluated at x is equal to that. I should have had it on the other side. So I'll do that down here. Actually, I'll write it right here. So f plus g of x is equal to, now what we want to do is combine whatever we can here. So 3x squareds plus 2x squareds, that's going to give me 5x squareds. And then 7x's, take away 1x, that is going to give me 6x. And then there's going to be a minus 1. So f plus g evaluated at x is 5x squared plus 6x minus 1. And that is done. So now we're going to try this one. This one just switched it and made it a minus sign. So it's the same deal, same exact functions as before. There's f, there's g, and we want f minus g of x. So what I'm going to write is f take away g evaluated at x is going to be equal to, all right, the f function was 3x squared plus 7x minus the g function. Shoot, I meant to do that in black, but oh well, we'll do it in red. The g function is 2x squared minus x minus 1. And now at this point, this minus sign, it has to get distributed to everything in there because we are subtracting the entire g function. So it actually is now 3x squared plus 7x minus 2x squared plus x plus 1. And then we'll put together our like terms. 3x squared take away 2x squared. That gives me 1x squared. And then 7x put together with x. That makes 8x's. And then there's a plus 1 on the end. So this is f minus g evaluated at x. And I should probably put this here as well. So there is the subtraction. Now we're going to do a multiplication because it would just make sense. Now, multiplication is a closed dot. I couldn't make the closed dot show up, so I'm just writing it in. It is f times g of x. So we are going to find f times g evaluated at x. So I need to write my f function first, which is 3x squared plus 7x. And I am going to multiply it by all of g of x. So that is 2x squared minus x minus 1. And that now, notice it's a binomial times a trinomial. You can either FOIL that thing out, or I am going to choose to do a box method here. This is just going to be my work to make this happen. I'll put the 3x squared plus 7x here. And then the 2x squared will go here minus x minus 1. And I'm just going to fill things in. So 3 times 2, that is 6. X squared times x squared is x to the 4th. Minus 3x to the 3rd plus 3x squared. And then 14x to the 3rd minus 7x squared minus 7x. And then what we want to do is combine like terms. So 6x to the 4th has nothing similar to go with it, but these two can go together. So 14 take away 3, that is going to give me 11x to the 3rd. Negative 7x squared plus 3x squared, that's a minus 4x squared. And then that poor lonely minus 7x is tagged on the end. This is what f times g evaluated at x is. So that will be my answer for that. And yeah, I did have to do a little work to get there, but you know how to multiply. And so that is what we're headed towards there. Now we have the last one here. Same exact set of things. This is now division though. So we want f, oops, black marker again, f divided by g evaluated at x. So if I want f divided by g, I'm going to put f on top. So 3x squared plus 7x over 2x squared minus x minus 1. Well, it is important for me to always know whether or not my denominator can ever equal 0. The only way I'm going to know if my denominator can equal 0 is if I attempt to factor it. So here is 2x and x. There's a 1 and a negative 1. And 2x minus 1. That gives me, this is an x, this is a negative 2x. That would give me negative x. So I know my denominator, I'm going to just come over here to write it, is going to be the 2x and the x, and now the 2x has to get multiplied by the -1, so that means the -1 has to be in that parenthesis. The +1 will be here. And then what I also want to do is attempt to factor this, and the only thing I can do there is greatest common factor. So 3x plus 7. Now in this particular case, absolutely nothing can factor, but I do know that x can't equal 1, nor can it equal -1/2. So the 1 comes from this factor here. I don't know why I did them the other direction. And then the -1/2 comes from this factor here. If you set them equal to 0, that's when they'll go to 0. So if we let x equal either one of those, we know we're going to have an error. So I can finish it out and I can say, all right, f divided by g of x will always equal 3x squared plus 7x all over 2x squared minus x minus 1, as long as x does not equal -1/2 or 1. So x just isn't going to equal whatever turns that denominator into 0, because that is where we would have our issues. Now, we do have a couple others that we could practice and try. So I'm going to let you get this written down. No, I don't know if I can pause it. I'll try. I'm going to get out of here and pause it. So f of x is 2x squared plus 5x plus 2. G of x is 3x squared plus 3x minus 4. What you want to attempt to do is add them together and get your answer. And actually, I'll just wait a little bit because I don't know how to find my pause right now. And we should end up getting letter A. That is going to go to 5x squared plus 8x minus 2, because we're just going to add them together. If I do a subtraction one, same exact problem, f of x take away g of x. I'm going to give you a moment to look, or pause it. Actually, that's better. You pause it, you look, and now I'm going to start. So if I subtract it, 2x squared take away 3x squared, that does give me a -x squared. 5x minus 3x, that gives me a positive 2x. And 2 minus a -4 is a positive 6. So the answer choice that matches best is down here with letter D. Now, if we did a division, let me see if I can copy this in order to bring it along with us. Yes. So what I am going to do is insert page here. We're going to just switch this over to multiplication. So if they wanted us to multiply it, you guys pause it, see if you can check and see what you get here. I will see if I can pause it as well. You will see my work momentarily. Okay, so I'm thinking you guys got there, and what, oh, I don't know why I wrote division here. This is not division. This should equal multiplication. I got 6x to the 4th. I'm going to erase that. F times g of x should be equal 6x to the 4th plus 21x to the 3rd plus 13x squared minus 14x minus 8. And my work is all in there. If I made mistakes, please feel free to let me know. But I believe that checks. And I'm going to insert another page, and we will just do a quick division one. And get that in there. So now I'm going to do division with that. And so we would want f divided by g of x is equal to 2x squared plus 5x plus 2 all over our 3x squared plus 3x minus 4. You guys pause this again to check your answers. We'll see if I can do that here. All right, so the reality is on this one, it doesn't factor. It did not take me long to realize it won't factor, and if it won't factor, there is nothing that I can put in for x that'll turn it into 0, unless I do quadratic formula. But it's not going to be a nice number, so we aren't going to panic and write that down. And I think for this particular section, so there is the division and the multiplication, we are not going to go beyond that. We're going to stop right there. That is not your assignment. Let me pause this. I'm going to wish you luck. Please make sure you let me know if there was anything on there you didn't understand. And let's see how this goes.